Module 7, Internet-Based Connectivity. Internet-based connectivity options. In modern WAN connectivity options do not end with Ethernet 1 and MPLS. Today, there are a host of inter-based wired and wireless options from which to choose. Internet-based broadband connectivity is an alternative to using dedicated WAN options. The figure lists the internet-based connectivity options. Under the broadband VPN, there are two options divided into wired and wireless. Under the wired connectivity, there is an XDSL, cable, and optical fiber. And under wireless, municipal Wi-Fi, cellular, satellite internet, and WiMAX. Internet-based connectivity can be divided into wired and wireless. The wired options use permanent cabling, for example, copper or fiber. This is to provide a consistent bandwidth and reduce error rates and latency. Example of wired broadband connectivity are digital subscriber line or DSL, and cable connections, and optical fiber networks. And then under the wireless option, the wireless options are less expensive to implement compared to other WAN connectivity options because they use radio waves instead of wired media to transmit data. However, wireless signals can be negatively affected by factors such as distance from radio towers, interference from other sources, weather, and number of users accessing the shared space. Examples of wireless broadband include cellular 3G, 4G, and 5G, or satellite internet services. Wireless carrier options vary depending on locations. And the DSL technology, digital subscriber line, is a high speed and always on connection technology that uses existing twisted pair telephone lines to provide IP services to users. DSL is a popular choice for home users, for enterprise IT departments to support teleworkers. The figure shows a representation of bandwidth space allocation on copper wire for asymmetric DSL. So if you notice that the figure shows that the area labeled POTS, or the plain old telephone system, identifies the frequency range used by the voice-grade telephone service. The area labeled ADSL represents the frequency space used by the upstream and downstream DSL signals. The area that encompasses both the POTS area and the ADSL area represents the entire frequency range supported by copper wire pair. And there are several XDSL varieties offering different uploads and download transmission rates. However, all forms of DSL are categorized as either asymmetric DSL or ADSL or symmetric DSL or SDSL. ADSL and ADSL Plus provide higher downstream bandwidth to the user than upload bandwidth. SDSL provides the same capacity in both directions. The transfer rates are also dependent on the actual length of the local loop and the type and condition of the cabling. For example, an ADSL loop must be less than 5.46 kilometers, and that is equivalent to 3.39 miles for guaranteed signal quality. Security risks are incurred in this process but can be mediated with security measures such as VPN. So the DSL connections, the service providers deploy DSL connections in local loop. As you can see in the figure, as shown in the figure, the connection is set up between the DSL modem and the DSL access multiplexer, or the DSLAM. The DSL modem converts the Ethernet signal from the teleworker's device to a DSL signal, which is transmitted to a DSL access multiplexer at the provider location. DSL AM is the device located at the central office of the provider and then concentrates connection from multiple DSL subscribers. A DSL AM is often built into an aggregation router. The advantage that DSL has over cable technology is that DSL is not a shared medium. Each user has a separate direct connections to the DSL AM. Adding users does not impede performance unless the DSL AM internet connection to the ISP or to the internet becomes saturated. The DSL and PPP, or the point-to-point protocol, is a layer 2 protocol that was commonly used by telephone service providers to establish router-to-router and host-to-network connections over dial-up and ISDN access network. ISPs still use PPP as the layer 2 protocol for broadband DSL connections because of the following factors. Number one, the PPP can be used to authenticate the subscriber. PPP can assign a public IPv4 address to subscriber. And PPP provides link quality arrangement for features. A DSL modem has a DSL interface to connect to DSL network and an Ethernet interface to connect to the client device. However, Ethernet links do not natively support PPP. As shown in the figure, the host with PPOE client, the host runs a PPOE client to obtain a public IP address from PPOE server located at the provider site. The PPOE client software communicates with the DSL modem using PPOE, and the modem communicates with the ISP using PPP, or the point-to-point protocol. In this topology, only one client can use the connection. Also notice that there is no router to protect the inside network in this kind of topology. Another one is the router PPOE, but it's not showing. Router PPOE client, another solution is to configure the router to be a PPOE client. And the router is the PPOE client and obtains its configuration from the provider. The clients communicate with the router using only Ethernet and are unaware of the DSL connection. In the topology, multiple clients can share the DSL connections as compared with host with PPOE client only. Now, cable technology. The cable technology, this is a high-speed, always-on connection technology that uses a coaxial cable from the cable company to provide IP services to users. Like DSL, cable technology is a popular choice for home users, for enterprise IT departments to support remote workers. Modern cable systems offer customers advanced telecommunication services, including high-speed internet access, digital cable television, and residential telephone service. The Data over Cable Service Interface Specification, or DOCSIS, is the international standard for adding high bandwidth data to an existing cable system. Cable operators deploy hybrid fiber coaxial, or HFS or HFC networks to enable high-speed transmission of data to cable modems. The cable system uses coaxial cable to carry radio frequency signals to the end user. HFC, or the hybrid fiber coaxial, uses fiber optic and coaxial cable in different portions of the network. For example, the connection between the cable modem and the optical node is coaxial cable, as you can see in the figure. The optical node performs the optical to RF signal conversion. Specifically, it converts RF signal to light pulses over fiber optic cable. The fiber media enables the signal to travel over the long distance to the provider headed where cable modem termination system, or CMTS, is located. As you can see in the figure, the headed contains the databases needed to provide the internet access, while the CMTS is responsible for communicating with the cable modems. All the local subscribers share the same cable bandwidth. As more users join the service, available bandwidth may drop below the expected rate. In fiber optical fiber, many municipalities, cities, and providers install fiber optic cable to the user location. This is commonly referred to as fiber to the X, or FTTX, and includes the following. Number one is the fiber to home, or FFTH. In this scenario, the fiber reaches the boundary of the residence. Passive optical networks and point-to-point Ethernet are architecture that can deliver cable TV, internet, and phone services over FTTH network directly from the service provider central office. Second one is fiber to building. The fiber to the building, the fiber reaches the boundary of the building, such as the basement in the multi-dwelling unit, with the final connections to the individual living space being made via alternative means like curb or pole technologies. And the last one is the fiber to node neighborhood, or FTTN. Optical cabling reaches an optical node that converts optical signal to a format acceptable to twisted pair or coaxial cable to the premise. FFTX can deliver the highest bandwidth of all broadband options. So these are the internet-based connectivity.